computational resources. And Edge has least latency, but it doesn't have as much computational power as you have in the cloud. So Edge can, Fog can bridge the gap. And this is from our one of our works, the same. I think this is from another work of ours, but related to it. So basically, this was related to 6G, that how sixth generation network plans to improve the quality of communication and infrastructure access using AI and different technologies. So here I have mentioned different technologies on these two sides and the bottom, and mentioned latency and the storage and processing. So what does Imtidad do? So we built this prototype. So we use laptop as a fog computing resource. We had different edge devices, and we have clouds, which is Google Colab. Okay, so here are some details about each of the hardware. So you have Raspberry Pi, you have NVIDIA Jetson Nano, you have mobile phones, and you have the laptop. Okay, and this is the reference architecture. So basically, we one step is to develop and deploy the services. So for example, this is our reference architecture. So we say that you can select an application, you can acquire the data, you can design a model or more than one models, then you can design service use cases, design a service, design service catalog, execution platforms, decide about what different execution platforms will be there, talk about consider supported networks, and then operationalize the services. User selects the service, requests the service, and then receives the results, and validation is done by domain professionals and benchmarking. Okay, we will talk about each of these steps. I mean, as it says here, that Imtidad is an Arabic word, which means extending or extension, basically from cloud to edge point of view. So here we have 22 services, and I will show you those services. We have 4 service classes based on software platforms. One is on gRPC, containerized gRPC, Android, and Android Nearby. Hardware platforms, we have Google Cloud, HP Pavilion laptop, NVIDIA Jetson, and all these I have explained. Networks are fiber, cellular, Wi-Fi, and Bluetooth. Deep learning diagnosis models, 2 standard deep neural networks, and 2 tiny AI deep models. Okay, tiny for the edge. And these are different classes for the diseases. Okay, so here some more meat into the reference architecture. From reference architecture to you can call it workflow diagram or whatever. So application selection I mentioned. So in this case we selected a skin diagnosis. Dataset acquisition, we got this dataset. Model design, here are the details. Service use cases, for example, looking at business models, patient self-diagnosis, on edge, fog, and cloud, flexible tools for medical professionals. For example, diagnosis can be done en route to hospital. Diagnosis can be done on cloud or fog en route to home. Diagnosis on smartphone en route to conference. So, for example, what we are saying here is that a doctor or a professional, she might be en route to a hospital or home or to a conference, and she can use either the smartphone or connect to fog or connect to cloud. In terms of service design, you have mobile local service, mobile remote service, gRPC service, containerized, and diagnosis request service. Service catalogs, you have service type 4 service types, 22 service specific services, and then benchmark development. So we have looked at service value, energy consumption, response time, process time, network time, data transfer rate. Then we select execution platforms, as I said, and these I already mentioned. Networks I already mentioned. Service operations, we operationalize the service, and service can be selected using type, platform, and model. And then you can request diagnosis and receive diagnosis, and validation, benchmarking, and medical professionals. I've mentioned this already, okay? So this is the Imtidad reference architecture with more information inside. And as I said, I will not go in detail. You can find all these papers have been published, and you can find the details there. This is the service catalog. So you have the service name. You can see the services are named by the layer, cloud, fog, or edge. And service types here, I mentioned to you already 4 service classes. Layers mentioned to you already, 3 layers. Platforms I mentioned to you already, whether cloud or fog or edge. And platform specification for each of these. For example, Jetson Nano, NVIDIA, GPU 128 core Maxwell, CPU quad core A57 at 143 gigahertz, and 4 GB memory. So similarly, you can find here platform energy. So it shows that how much energy these platforms consume. Network specification, fiber and so on. And, for example, what is the data rate and so on, wireless, LAN, and others. Latency for each of the services or platforms or networks. So based on that, it's written here. For example, in this case, where you are using cloud, it depends on the network, because if the network is fast, then you are able to go faster. Otherwise, it will take you longer. And these they explain the latency, for example, partially configurable based on what kind of network you are using. Models A Lite, B Lite. I mentioned to you we have 2 models, and we have 2 Lite models to run on the in the edge. So this gives detail about each specific service, that what model is being run in that service. Okay, so here's a diagram of services. So you have diagnosis request service, you have gRPC service, you have mobile remote service, DL model service, which is deep learning model, containerized gRPC service, and mobile local service. So these different services exist, and they talk to each other to carry out the user's request. This is the data set characteristics, and these are model details, AB. This is the user interface. So for example, you go on mobile, you say service type, and then from service type, then once you have selected a service type, then you decide about a device, then you decide about a model, and then you run it. Of course, these can be automated, but here it is just to show that that user can select them, or it can be automated. Okay, so here are some results. So processing time average and box plots. So you can see that processing time is the highest for Jetson. The reason is that Jetson, for these models, so these are, the blue color is A, light blue color is B, and this is the orangish color A light, and light orange color is B light. So what you see is that B light uses the least processing time, and A light uses the next, and then the B, and then A, but it can vary based on different devices. So why you have the highest time for A on Jetson Nano? Because A is heavier, and Jetson Nano is a edge device, so it is suitable for edge. So that's why. So you see on cloud, this time is low compared to others. For some reason, you see that cloud is using higher time than fog. Then you can compare the other results as well, and you see that B light is very small compared to the other ones. Okay, and this S9 and Note 4 are mobile phone. So here you have the variations for each device. You can see, for example, for Jetson, for blue, the variation is very high, and then you see light orange color is very low. Okay, so next one, response time, which includes both processing time and network time. So I think that there is a mistake here. These 2 figures are same, or no, they are not same. Anyway, I will check it, but these are available in the paper. Okay. So what you see here is that in terms of response time, it is relatively proportional to the processing time, but it depends on the network. So if the network has more random situation, then it will increase the response time. But these are average times, and these are a box plot with variations. Okay, so here is the network time, how much time it takes on the network, and what you see here from the color. For example, this one is yellow color, this is Node 4, and so on. So the highest time is for Node 4. Okay, And the explanation of these results are given there. Okay. Again, there is a box plot there, and network time here, and service data transfer rate, energy consumption, service E value, which we calculated based on some characteristics. So that includes the cost and so on, so that user can decide which service is best for it, or it can be automated based on that. Now the second case study. So I took a little time on the first case study. I have to move fast now. So what we did during COVID-19, we collected data from Twitter, and we tried to understand that how public responding to government pandemic measures, and how what is happening during the pandemic. Okay, so I will. So, for example, here's some detail that what has happened, and so on, and details about our work. For example, we use 14 million tweets from this period, and so on. So, as I said, I will go fast and just explain the results. So here, what you see is that these are detected automatically from Twitter data. And what you see is that we detected firstly that there is a COVID-19 start, staying home, instructions have been given by the government, prevention measures have been introduced, government started giving loans because the industry has been affected, people's economic situations have been affected. Hospital treatment has become an issue because people are, quarantined. Official quarantine starts. Mobility becomes an issue. It means that the opposite of generally when there's a lot of traffic here, it shows that there is low mobility. There is very little traffic. Curfew has been imposed by the government. Cleaning services have been introduced by the government, cleaning the road, toilets, and other things. Salaries are being given by the government. Quarantine ends. Hospital treatment ends. Hospitals start treating other diseases as well, not just COVID-19. As we know that during COVID-19, a lot of people did not get treatment for chronic diseases and so on because there were not enough doctors, and this was all emergency. Then we have 5 daily prayers because in Saudi Arabia they were banned in the mosque. So then they opened the mosques, and quarantine ends and back to normal. And this is not, fully normal. And these are the time periods from this 14th March to sometime end of May. Okay, here different concerns which have been automatically extracted from the Twitter data. For example, COVID-19 cases, supplications by the people, quarantine, 5 daily prayers, and some of these you have seen in the previous diagram. And this shows intensity of these issues during this time. Okay. So because of time, I will not be able to go in detail. Here we have different macro concerns, and we talked about that. Also, we linked it to the geography. So these circles show that how much activity is there for a given parameter or concern, government public concern. So bigger means there are more activities. For example, here Jeddah, near Jeddah, you have Makkah. So there's a lot of activity because of course, people want to pray in the Haram. So there's a lot of talk here. So these colors show the different regions, and the size show that how much is the activity. Okay, and this is Saudi Arabia map. And this relates to the curfew on 2nd of April 2020. How do we do that? So we collect data from Twitter and other data sources. In general, we do the pre-processing, we measure, and we detect the measures and concerns. So government measures and public concerns, we detect them using these. And then we have a spatiotemporal information component which extracts the time and the space of the information, and then we do the validation. Okay, so because data is large and it takes a long time to process this data, so here we have experimented with different number of cores. So here from 24 to 168, and this is the time. So you can see that this is in hours. So if we use 24 cores, it takes us 163 hours. So if you multiply 24, 25. So I think this is like 6+ days. And if you use 160 cores, then it takes you 24 hours roughly, which means 1 day. So we are able to bring from 6 days to 1 day, then we can go, of course, further as well, based on how much data is there, how much you can go down. But from 6 days to 1 day is a big win. Here, the same thing is explained using a number of iterations for the models. That if you have higher iterations, then you need more time. Okay, third case study, Musawa. Musawa means justice or sustainability in Arabic. Okay, so again, I need to go fast. So here we introduced cancer services using Twitter data. So we try to understand that what requirements are there, and that these requirements can be turned into services. And if these services are there, what resources are there, and so on. So again, as I said, that the paper is available, you can read in detail. So what you see here is that you have prevention. Okay, so for example, you can have symptoms, early diagnosis, and so on, and each of these can be converted into services. Information availability, questionnaires and competitions, breast cancer awareness campaigns, socioeconomic sustainability, financial support, government support, socioeconomic and operational challenges, charity organizations for cancer, psychological support for patients and their families, and treatment options available. So I will not go in detail, but basically we zoomed into different stakeholders and different issues and try to understand them. And these provide that information you can see in the paper. DNA profiling. So DNA profiling, basically what you can do is that from DNA you can, for example, there are multiple uses of DNA profiling. So one use is that you can use it for paternity tests, for example, to find out that who is the father of a child. One important application is that on a crime scene, if there are blood samples available and these blood samples are in mixture, then you can find out that who are the constituent of these blood samples. Because typically on a crime scene, you see multiple blood, and this might be mixed. So DNA profiling can help us to find criminals, and here there's some history, and you can find it there, as I said, introduced in 1985 by Alec Jeffreys, and these are the applications. Okay, so disaster victim identification is another of the application, because when disasters happen, it is difficult to find who died and so on. Missing person investigation can be done as well. Okay, so here we try to, so this problem, the first problem in this case is to find out that how many unknowns are there in a mixture, in a blood mixture. So these are some details, some results about different number of unknowns in the sample. And what is the probability of finding the number of unknowns? Okay, so then another extension of this work is using likelihood ratio, where you compute the likelihood ratio of number of unknowns. And at the time of work, maximum reported was 4, 5. And we went up to 10 unknowns, and we used 3,000 plus scores, and we were able to bring the time from 5.8 to 2.7 hours. And we used a distributed MPI implementation. That was also the first distributed MPI implementation. Okay, detecting diseases from Twitter. So this work, we call it Saha, which in Arabic means health, Saha. So in this case, we try to, from Twitter data, try to find out what diseases are there and what is their proportion. And then we compare them with the national statistics, and we found a good correlation between them. And what you see here is that DRD is dermal disease, diabetes, heart disease, hypertension, CNR cancer, and then you have these other diseases. So these are the top diseases in Saudi Arabia in terms of number. And basically, you can see the largest number is this one, diabetes. and then after that you have hypertension, and then dermal disease, and heart disease, and then cancer. Okay, so then there are different variations of that, trying to apply some processing on the data and improving the results and so on, looking into different cities. For example, here you see that this black color is all Saudi, Riyadh is this color, and then Taif is this color. Typically, we found that Taif had the lowest diseases in the whole kingdom. And Taif is, you would have heard about Taif here. Professor Allah went there. It's a high place on top of the mountain, and people are more healthier. I think they are healthier than. Okay, so then we also looked at awareness versus afflicted cases, trying to understand that if we create awareness, does it help with diseases, their prevalence of diseases? So we found a good correlation between them as well. Okay, then this work, I think that I will go now very fast because otherwise I will not be able to finish it. So this work, UB Health, I will go here. So we basically try to develop an infrastructure, computing and network infrastructure and it includes cloudlet. The time we did cloudlet was more common word to use, but cloudlets are like edge computing. So basically, we looked at security and efficiency. We developed a proof of concept. We looked at network quality of service, introduced a framework for that. And here there are details about how we use machine learning to control the traffic and mine the traffic and so on. Okay, psychological health. So I will go directly to the results. So this is a diagram of how we do it. So psychological drug, again, we did it from cancer data, Twitter data, and we try to understand what is the situation with psychological health, what different issues are there. So there are social and economic factors like poverty, high cost of healthcare, loss of loved ones, and so on. Treatment options, what treatment options are there. Individual factors, for example, anxiety, sadness, poor concentration, poor memory, and so on. Disease disorders, and treatment limitations. So, for example, antidepressant limitations, they work, they don't work, negative effect of antidepressant. We also try to correlate these with different medicine, that what different medicine is being used, and what is the correlation between the medicine and these factors. Okay, education governance. So we looked at, because during COVID-19, there was a issue with going to school, so that schools were moved to online. And so we looked into this transition online, and then we looked at back to the in-person teaching, the physical classroom transition as well. So we looked at success factors, for example, in-class pandemic measures, awareness activities, supporting online learning, commending stakeholders, for example, teachers, parents, and students, digital services. What was the situation? People talked about that, it's not working, the network connection, all that thing, nurturing positive behavior. So disseminating information about things, talking about values, goodness, and so on. Socioeconomic sustainability, the benefits, what new economic opportunities came because of that, because the economic conditions were affected all over the world. But in Saudi Arabia, and of course in other places, people found different ways of earning money. For example, converting slides to digital formats, helping teachers or whatever parents to deal with the situation. Challenges, education system in class versus online, exam procedures and school timings, they were the challenges.
Excuse me.
Yes.
It's a wonderful sort of stuff, and genuinely, we wish to listen in very deeply. But on the other hand, we have some time-related issues.
Okay.
I would request to please
Okay, can you listen
precise it
to
so
me?
that we can have some question answer
Yeah.
session.
Yeah. Okay. Let me say that we start at 8:10 almost. And you told me 30 to 35 minutes, so I have still 10 minutes. You want to just close it? I can close it. So tell me, please. Oh, you are late.
Please
It
proceed.
started.
But if it could be, please precise it.
Yeah, but understand, please, that you are late. Okay? I was in time and you are late. You want me to stop or continue? Because I have 10 minutes and you want me to continue, I will continue. Otherwise, I can stop. Okay, so this was the last one, and now healthcare challenges. Um, so, what are the healthcare challenges? Access to care, affordability and rising costs, quality of care, and so on. I have mentioned it here. What are trends? Digital health and telemedicine, wearable technologies, AI, machine learning, personalized and precision medicine, healthcare, consumerism, and so on. Future of healthcare. So here are some uh, trends which I have outlined here, which are for future, and I will talk about them one at a time. So digital health and telemedicine. So, because of the time, I will just go fast. I will just mention them. So, we know that telemedicine is becoming an important driver in the future of healthcare. AI and machine learning, we know already. Precision medicine, as you know, going on the DNA levels and beyond. Regenerative medicine. So, we are trying to regenerate organs and cells and all that thing. Interoperability of healthcare systems is very important because if we can integrate different data, then we will be able to understand diseases better and we will be able to cure them better and so on. Sustainable healthcare. Um, there is a trend on improving the sustainability of healthcare. For example, the plastic syringes and all these plastic uh, things we use in healthcare, they are damaging the environment significantly. So there is a trend on that side. Global health initiatives is another trend. WHO coming forward. You have seen um, the Bill Gates and all that thing that they are trying to bring it together because of COVID-19. It affected it internationally. Aging population is a major issue. I think in Pakistan it's not as much as in the other countries, but it is going to affect all the countries because people are not getting married, they are having less children, and so on. So therefore, the overall population age is increasing, and therefore more load on the healthcare system. Mental health is becoming a calamity in particularly in the Western countries and advanced countries because of the lifestyle and so on. Regulatory and ethical considerations are very important now because a lot of new laws have been enacted about privacy, about AI, and so on, and therefore there is going to be a lot of work there, and people have to be aware of it. Healthcare education and workforce development is another issue that there are not as many people moving into healthcare workforce. Good skilled people. So this is another issue. Patient empowerment and engagement. This is another issue. If we can engage the patients, then we will be able to better manage their health. So conclusion, we are in unprecedented and exciting times, and let's work together to make the world a better place. There's some special issue I'm organizing, but actually we have closed them now because I put it some time ago. We just closed them. Okay, these are some of my details, and I'm listening. So actually, I did not take even 35 minutes. I took 29 minutes because I started around 8:10, and now it's 8:39. So let's say 30 minutes. Okay, I'm listening now.
Thank you very much, Dr. Rashid. It was genuinely a research piece to listen to you. You just started from Imdad, proceeded to very dynamic models like Musaba, Seha, and UB Health. And as far as my own perception is concerned, it is comprehensively addressing the issues related to COVID, cancer, some sort of skin diseases, as well as their related psychological issues. And as it was titled, it was addressing its future dimensions as well. And you proceeded with the regenerative medicine, healthcare system operability, wonderful issue. Then sustainable healthcare systems. You addressed the aging population related issues and correspondingly their regulatory and ethical issues. Thank you very much for your deep insights, and these were really wonderful. I open the house for any sort of the question from the audience, please.
Assalamu alaikum, sir. I have a question. You have explained very well, but I have a little question regarding your accuracy. How you can manage your accuracy to diagnose multiple diseases, like you have discussed about 3 to 4 different type of diseases, and you collect data from the patients and use cloud-based scenario, and how you can tackle the issue regarding accuracy?
Okay. Machine learning accuracy. So, see that case studies, and every case study can have different machine learning models, and every model and based on the data can have different accuracy. So what we do is that we try to validate the results by different means, and of course, machine learning accuracy is an issue. It's not 100%. So I can only say that we all are aware of machine learning accuracy, and for a specific case study, we try to optimize, improve the accuracy as much as possible. For example, using better models, using multiple data sets where we have available, or uh, validating the answers which get with the real data. So for example, if you are diagnosing a disease, a skin disease, so you get yes, no, whatever classification you are doing, and then you try to talk to the, so you have the domain expertise, and they apply the domain expertise and try to improve it. So I think that this is a general issue, and the solution to that is that humans are in the loop, and they have to check the accuracy of the result. Just like we talk about GPT and say GPT can make mistake, hallucinate, whatever. So similarly, in numerical data, we do the same thing, that machine learning can make mistakes, so it has to be validated by humans. And this is one of the regulations which are coming up, that humans have to be in the loop of all AI systems. So on one hand, we are trying to remove humans, but on the other hand, the regulations are going the opposite. And the reason for that is that if machines are going to make decisions, all of the decisions, and we know that they can make mistakes, then eventually the whole system can collapse. So I hope I gave you the answer. Because of the time, I would stop here.
Any specific noise detection technique you have used in your model?
Any specific
noise detection technique? Because we are working on a cloud-based system.
What detection technique?
Noise.
Noise. Okay. Noise in the data, you mean? Noise in the data, you mean?
You used a variety of data.
What data, sorry?
Because you are using a variety of data and collect through a cloud-based system, and obviously you will face noise problem also.
Yeah, so data noise or network noise or what noise?
Network noise.
Network noise. Okay. Uh, so you're talking about when the data moves from cloud to edge, for example, right?
H, yeah.
Yeah. Okay. So network noise. I mean, um, I mean, you can go deeper and look into network noise. But for example, we have looked into filtering and so on. We can look into noise network. This is not something we have looked at. Uh, I mean, of course, the noise, and you can validate it. I mean, there are ways to validate it. For example, you send multiple and verify it. There are different techniques available. So, but we haven't looked at network noise. We are talking about data. Data noise generally is, you do pre-processing to clean data basically, and hope that it bring additional data sets and use different techniques uh, um, to take care of the missing values and so on. So, yeah, I mean, if you are talking about network noise, we haven't looked at network noise, but this is something that, there are general techniques available for that. Okay, I'm listening now. Um, I don't hear anything. I don't hear anything. I can't hear anything. Should I leave? Is it finished the talk?
ठीक है कुछ हाँ
जी सर.
जी सर आवाज आ रही है
Yeah, I can hear you. Yeah.
ओके अच्छा सर मेरा अदनान आबिद बात करूं मेरा सवाल ये है कि आपने काफ़ी सारी चीज़ें हेल्थ केयर पे और एजुकेशन पे की तो इनमें से कितनी चीज़ें प्रोटोटिपिकल लेवल पे थी और कितनी फिर फर्दर प्रोडक्शन में गई और उस पॉइंट ऑफ व्यू से चैलेंजेस क्या हैं प्रोडक्शन में ले जाने की ये इतने काफ़ी सारे ये यूज़फुल और एप्लीकेबल चीज़ें हैं तो उस पर हमें गाइड करें ताकि जब हम इस तरह का काम करें तो उसमें क्या प्रिकॉशंस हैं और किस तरह से उनको सॉर्ट आउट किया जा सकता है ऐसे इश्यूज को प्रिएम्प्टिवली
सही है प्रोडक्शन लेवल से अगर आप बात ये है कि उसको इम्प्लीमेंट किया जाए रियल लाइफ में सो दैट देयर विल बी इम्पैक्ट I mean, you see that, for example, the work, certain work which we have done, it relates to government. And unless we are aligned with the government and government allows us to start working on developing intervention methodologies and strategies and allow us to take steps, then we can't do anything with that. In terms of commercialization, we haven't commercialized any of these works which I have talked. But generally, you can make effort to commercialize. For example, you want to work on DNA profiling, you can talk to a company in you can find a company in Pakistan or international company and you can talk to them and say that we have developed this thing. And depending on the quality of the work and how much resources you have, you can commercialize. Basically, commercialization requires time, resources, and effort. Certain things we have done it, other things we haven't done. For example, services. We are working on services. We haven't implemented any of those services which we talked about. DNA profiling. Normally, what happens is that you have a team and they are working, and eventually they move forward, and then therefore you are not able to continue. So I think that on you, then how you want to go in a particular direction. So if you have some work and you want to take it to commercialization, you need to put time into it. If you put time, you will be able to take it forward. Okay.
Now I would like to introduce our second invited speaker, Dr. Adnan Abid from the Punjab. Dr. Adnan Abid is a professor of data science at the University of the Punjab, Pakistan, with over 22 years of experience in academia and industry. A senior member of IEEE and ACM, he earned his PhD from Politecnico di Milano in 2012. Dr. Abid was published 100 plus research articles and earning 4,000 plus citations and H-index of 29 and serve on editorial board of leading journals. He is also the co-founder of the AI company Tactics.ai. The title of Dr. Adnan talk is Empowering Collaborative Applications Development, a robust framework for ad hoc distributed systems. Sir, please take the stage.
Thank you very much, Dr. Saab, for your gracious introduction. Okay, so what I will be talking today is about a recent research work that we have concluded, and it is more towards software engineering and kind of distributed systems and collaborative spaces. So our research group, one of our PhD students has concluded his PhD on this topic. So I thought it will be a great time. He's about to present his thesis, the public defense. So I'm going to mock his public defense today, kind of. Yeah. So it's about a robust ad hoc collaborative space for customized mobile application development. So since we have a lot of mobile devices these days, and ubiquity of these devices is again something we all cherish, and we are now mobile device is kind of a part of our body more or less. So we take it everywhere and we use it everywhere. So as Dr. Rashid has just explained that through mobile and edge devices, they are trying to accomplish a lot of tasks for education and healthcare. So exactly in the similar fashion, we have also tried to solve a problem considering the fact that in most of the cases we have fixed infrastructure which is always there and we rely on that, but at the same time there are situations when we do not have a fixed infrastructure. So in the cases where we do not have fixed infrastructure, we need to have a specialized setting, and our applications which are running on these devices or the potential communication among these devices will certainly hamper. And particularly speaking in terms of the ad hoc systems, the idea is that now the device is connected and now the device is not connected. So there is a situation where the intermittent network failures are very common. So if at all we are running a collaborative application which is being run on multiple devices, So in order to run that efficiently and to ensure the availability and synchronization, we need to work on kind of a framework. We need to develop a framework so that we should be able to build such applications with a great deal of abstraction and ease. And at the same time, the framework should manage and handle these kind of discrepancies and disconnections, the intermittent failures in terms of the networks. So let's quickly see a couple of scenarios and try to understand how this work can potentially help in different situations. So let's say we decide that, okay, we go out in the ground. Fortunately, I'm in a big university, and obviously out there in the ground, you will not have Wi-Fi connection, right? So for that matter, your mobile devices, if at all there is an application through which we can communicate. So I have a multimedia here, but there we won't have any multimedia, right? So what we can do is we can develop a collaborative application through which I can share my slides to all of you through my mobile, and you can get those slides and I can play around and I can run my presentation on your mobiles through my collaborative application, and we are not using any fixed infrastructure or mobile communication or anything like that. So what we are using is the ad hoc network or low-range communication protocols like Bluetooth and Wi-Fi direct, so through which the devices can communicate in a peer-to-peer fashion. So this is kind of an idea. Similarly, the people who are working in mines, they do not have, providing a fixed infrastructure over there or specialized infrastructure is very costly. And there are situations where we can have these disasters and all that, like we had a very grave earthquake in 2008. So all the communication infrastructure was destroyed, and in the northern areas of Pakistan. So during those situations, emergency situations as well, we can have such applications which can actually help us. And apart from that, there is for past few years, there are these vehicular ad hoc networks as well, whereby the vehicles can communicate with one another, and they also are on the go. So having a fixed infrastructure over there is obviously not tractable. So the objective of this work was to devise a framework so that we can build collaborative applications over this framework, and which can actually mitigate with the intermittent failures. And the second objective was that the framework should be available for the application developers so that they can easily build and develop applications or collaborative application, to be more explicit. And lastly, we thought that once we have that framework and its abstraction layers, then it's very important to evaluate the framework, that how efficient has it been, and to what extent with different type of settings is it offering its services, and it is able to manage the intermittent failures. So there are infrastructure-based systems, so we are kind of ignoring them as of now. And what we will more talk about is the ad hoc infrastructure-based systems. So there are different so there are different factors and corresponding parameters which come into play. So through the literature survey, we got to know about these 6 different factors and their corresponding sub-factors or parameters per se. So interaction style was the first one. The task distribution, visualization, and collaborative editing, these are different widely used interaction styles which have been used in the development of collaborative applications. Then interoperability, which is regarding the platform independence. Then subsequently ad hoc networking, which is the main theme of this whole activity. And collaboration, obviously, another important perspective. Self-adaptation comes into play when we have these intermittent failures. So obviously, in terms of software engineering, we have self-healing and self-adaptation and robustness with small little differences technically. So what we tried to accomplish was that the framework that we are going to propose is essentially should be self-adaptive. And then the last thing which we actually included in this scenario was general application development, so that the framework should be able to develop customized general purpose applications. So there are existing frameworks which are there to develop very specialized applications, but they are there to help developing those kind of applications only. So this is kind of more generic and abstract. I'm not, how many of you have heard about MapReduce? The MPI or MapReduce, the distributed systems framework. So they are parallel and distributed systems frameworks which actually help solving a problem over the devices by using their storage and processing capabilities. So अगर आप सब लोग machines हैं तो मैं आप सब लोगों को कुछ ना कुछ काम assign कर सकता हूँ. तो जो डाटा आपके पास है आप उस डाटा के ऊपर अपना काम करके और फिर किसी दूसरी मशीन को दे देंगे और वो मशीन फिर in turn उसका जो solved part है उसको further process करके complete कर लेगी काम. फॉर इंस्टेंस अगर मेरे पास सिंपल एग्जांपल क्या है कि पेपर्स मार्क होने आते हैं तो मैं आप सबको पेपर डिस्ट्रीब्यूट कर दूंगा, हर कोई अपने अपने पास पेपर्स मार्क कर देगा और उसके बाद मैं कह देता हूं कि आप 3 लोग जो हैं वो मिलके सारे टोटल्स कर दें. सो दिस इज काइंड ऑफ अ मैप रिड्यूस एक्टिविटी. तो ये MPI थी हमारे पास एक जमाने में, मैसेज पासिंग इंटरफेस लाइब्रेरी आज भी हैं, तो उनके थ्रू ये काम किया जाता था. उसमें काम की डिस्ट्रीब्यूशन और उसकी जो रिसोर्स एलोकेशन है और बहुत सारी चीज़ों का ख्याल जो है वो एप्लीकेशन डेवलपर को खुद रखना पड़ता था. सो व्हाट इज एब्स्ट्रैक्शन? एब्स्ट्रैक्शन इज हाइडिंग द कॉम्प्लेक्सिटी. सो इन दिस केस पीपल केम अप विद मैप रिड्यूस फ्रेमवर्क. मैप रिड्यूस ने क्या किया कि उसने MPI के ऊपर एक लेयर लिखी और वो लेयर क्या करती है कि अभी it takes care of so many different system level things. You just need to tell that okay, this is my mapping function जो कि मैप का जो कि एक एक्टिविटी परफॉर्म करेगा, कैसे किस डाटा पे, वो अंडरलाइंग फ्रेमवर्क इज टेकिंग केयर ऑफ दैट. सो एग्जैक्टली उसी नोयत का एक काम हमने यहाँ पे किया. What we have done is general purpose development के perspective से जो last point है, what I am trying to explain that is कि हमने एब्स्ट्रैक्ट फ्रेमवर्क डिफाइन करने की कोशिश की है ताकि उसके ऊपर कोई भी किसी भी तरह की एप्लीकेशन डेवलप करने की कोशिश करे तो हमारे फ्रेमवर्क के डिफरेंट कंपोनेंट्स के एक्सपोजिशन हमने दिया इन द फॉर्म ऑफ API सो दैट दे कैन कॉल रिलेवेंट फंक्शंस जस्ट लाइक मैपिंग एंड रिड्यूसिंग के अंदर मैपर फंक्शन होता है, रिड्यूसर फंक्शन होता है. सो एग्जैक्टली वी हैव आवर 5-6 डिफरेंट फंक्शंस जो कि people can call them in their applications and they will serve the purpose and it will eventually be completed. So this is a comparison of some existing available relevant frameworks. So down in the last row is our proposed framework. So you can see that based on all 6 previous factors, we have interaction styles, interoperability, ad hoc, network, collaboration, self-adaptation, and general purpose development. So the general purpose development is only associated with our proposed framework, and at the same time, self-adaptation is merely covered by the rest of the framework. So majority of the frameworks do not cover self-adaptation as well. So let's get to the proposed framework. So these are, so I would again take some time on this slide. हम जब सॉफ्टवेयर डिज़ाइन और सॉफ्टवेयर इंजीनियरिंग का कोर्स पढ़ रहे होते हैं तो उसमें मेजॉरिटी ऑफ द टाइम्स इवन फाइनल ईयर प्रोजेक्ट जब हम कर रहे होते हैं तो हम डॉक्यूमेंटेशन करते हैं. तो डॉक्यूमेंटेशन के अंदर हम फंक्शनल रिक्वायरमेंट्स लिखते हैं और उसी के साथ साथ हम नॉन फंक्शनल रिक्वायरमेंट्स लिखते हैं. तो नॉन फंक्शनल रिक्वायरमेंट्स हम बड़ी तेजी से 5-6 जो भी हमारे जहन में आती हैं, परफॉर्मेंस, स्केलेबिलिटी, यूजेबिलिटी, interoperability, we just keep on writing them whatever we know. But unfortunately many of us including myself, जब मैं भी अंडरग्रेड में था, इवन मास्टर्स में भी था, समझ कोई नहीं आती थी कि मैं क्या लिख रहा हूँ. So that's why I'm trying to kind of emphasize on this slide कि ये जो framework है ये इस नोयत के कुछ काम करने के लिए हमने establish किया और बनाया. तो synchronization, self-adaptation, robustness, data management, network management, performance, ये वो चीज़ें हैं जो कि ये framework address करेगा और करता है, और आगे चल के हम अपने results में भी फिर इन्हीं perspectives में से कुछ perspectives को explicitly अपने experimental setup के अंदर से टैली करके देखेंगे कि वाकई में ये इन चीज़ों को, इन पर्पसेस को सर्व कर भी रहा है या नहीं कर रहा. सो दैट्स गोइंग टू बी द टेक अवे, वन ऑफ द मेजर टेक अवेज दैट आई वुड लाइक मेजॉरिटी ऑफ द स्टूडेंट्स जो कि यहाँ पे बैठे हैं उनके पॉइंट ऑफ व्यू से कि आप इन चीज़ों को समझिए. जैसा रोबस्टनेस, सेल्फ अडेप्टिवनेस, ऐसी चीज़ें होती हैं कि जब मेरे सिस्टम के अंदर कोई गड़बड़ होती है, वो जिस तरह हमारे केस में कम्युनिकेशन अभी 2 डिवाइसेस की हो रही है और अब नहीं हो रही, तो जब वो डिस्कनेक्ट हो जाते हैं और उसके थोड़ी देर बाद फिर वो दोबारा कनेक्ट होते हैं, तो मेरी एप्लीकेशन को कैसे बिहेव करना चाहिए. So that is something we call robustness. होती है छोटे छोटे intermittent failures के point of view से कि उनको वो कैसे manage करते हैं. ठीक हो गया. इसी तरह self adaptation भी इसी का एक variant है. self adaptation क्या होगा कि जब कोई इस तरह के ad hoc settings में जब devices collaborate कर रही हैं तो उनमें से कोई device disconnect हो जाती है, या आप उसे हाइब्रिड पीयर टू पीयर में है तो आपका जो सुपर पीयर है वो अगर फॉर दैट मैटर थोड़ी देर के लिए अनअवेलेबल हो जाता है, तो कैसे अपने आप को एडजस्ट करना है. तो दैट इज, और ये हर सिस्टम की रिक्वायरमेंट तो नहीं होगी, ये तो जो इस फैशन में जो सिस्टम चलेगा उसी की ही रिक्वायरमेंट होगी. सो एसेंशियली वी नीड टू अंडरस्टैंड कि ये रिक्वायरमेंट सॉफ्टवेयर इंजीनियरिंग के पर्सपेक्टिव से हैं क्या. इसी तरह डाटा मैनेजमेंट जो है वो जब आप अक्रॉस द डिवाइसेस कोलैबोरेटिव एप्लीकेशंस रन कर रहे हैं तो उनके अंदर जो डाटा जनरेट हो रहा है और जो मैसेज पासिंग हो रही है, कंट्रोल मैसेजेस कौन से हैं, डाटा मैसेजेस कौन से हैं, और उनको कैसे सिस्टम ने अक्रॉस द मशीन्स और डिवाइसेस स्टोर करने हैं और प्रोसेस करने हैं. तो दैट्स व्हाट कम्स अंडर द डाटा मैनेजमेंट थिंग. और इसी तरह से आपकी परफॉर्मेंस और स्केलेबिलिटी और सिंक्रोनाइजेशन, ये चीजें भी आती हैं. सो परफॉर्मेंस इज फ्रॉम अ सिंगल यूजर्स पर्सपेक्टिव और स्केलेबिलिटी इज कि आपका सिस्टम एफिशिएंटली रन कर रहा है व्हेन यू हैव लार्जर यूजर बेस और प्लेंटी ऑफ डिवाइसेस पर से. So these are the major components of the framework. Controller, then there are plenty of services, network management, communication and storage. तो इसको इस diagram की मदद से समझने की कोशिश करते हैं. So once again, in terms of software architecture, there are plenty of architectural patterns or architectural styles. Overall, this framework is using layered architectural style or architectural pattern. So you see these different components of the proposed framework, they are separated across different layers. So this is the first thing to understand. Then let's quickly get through कि ये different components हैं क्या. So the first component or the brain of the whole system is the controller. Controller is actually managing or storing all the information which is out there. कौन से devices हैं, कितने डिवाइसेस कम्युनिकेट कर रही हैं, उन डिवाइसेस में से किस डिवाइस को ग्रुप ओनर का लेवल दिया गया है, और किस तरह से रेस्ट ऑफ द डिवाइसेस आपस में कम्युनिकेट कर रही हैं, मैसेज पासिंग कैसे हो रही है, कौन सी डिवाइसेस कौन सी सर्विसेज एक्सपोज कर रही हैं, और ये ओवरऑल सारी की सारी एक्टिविटी को गवर्न जो कर रहा है कंपोनेंट, दैट इज द कंट्रोलर कंपोनेंट. And then there are these small 3 different components on the next layer, which is the services layer, the network management layer and communication services. So the services layer is about the services or the programs that we want to run on this collaborative space. और इस collaborative space में जितने भी devices हैं उनके ऊपर वो program actually run करेगा, हर machine के ऊपर run करेगा और in a collaborative fashion. Collaborative fashion का एक simple manifestation आपको मैंने जिस तरह example दी कि हम बाहर जाएं और मैं अपने मोबाइल डिवाइस पे प्रेजेंटेशन रन करूं और वो आप सब लोगों के पास भी एप्लीकेशन हो, इसी की कॉरेस्पॉन्डिंग एप्लीकेशन, और उस पे भी वो प्रेजेंटेशन रन होनी शुरू हो जाए. एक और मैनिफेस्टेशन उसकी इससे ज़्यादा थोड़ी सी ट्रिकियर और रिलेटिवली चैलेंजिंग चीज़ क्या हो सकती है कि वी वर्क ऑन समथिंग, दिस इज काइंड ऑफ वन वे थिंग कि मैं आपके लिए कोई चीज़ शो कर रहा हूँ, और एक इससे ज़्यादा क्या हो सकती है कि हम पेंट की एप्लीकेशन खोल लें एंड वी ऑल स्टार्ट ड्राइंग ओवर देयर, हम कोई जिक्सॉ पजल है और वो हम कोलैबोरेटिवली सॉल्व कर रहे हैं, सो वी कैन डेवलप गेम्स एज वेल फॉर द चिल्ड्रन इन सर्टेन सिचुएशंस। सो उसके ऊपर क्या है कि वो मल्टी वे इंटरेक्शन स्टाइल जो है वो हमारे पास आ जाएगा और बहुत सारे लोग साइमल्टेनियसली उस पर कम्युनिकेट करें। सो एसेंशियली हमारे पास चैलेंज क्या है कि इस सारी एप्लीकेशन को सिंगल एप्लीकेशन के तौर पे हर एक परसीव करे और हर डिवाइस इसको सिमुलेट इस तरह से करे कि इट्स वन सिंगल एंटिटी जिसको सब लोग मिलकर इस्तेमाल करें। सो दैट्स द एसेंस ऑफ दिस कोलैबोरेशन। So for that matter we need to develop such services, और उन services को फिर in turn हमने discover करवाना है कि हर device अपनी service को expose करेगी in the first place, rest of the devices will figure out that okay this my device is exposing this service, I want to connect to it, और उसकी obviously छोटी मोटी security controls इसके अंदर हमने as of now क्योंकि ये prototypical form में है तो हमने इसको embed किया है और वो allow करता है तो दोनों devices आपस में collaborate करना शुरू करते हैं। This is how it actually starts, and then the network part comes in, और उसके अंदर नेटवर्क की मॉनिटरिंग और कॉन्फ़िगरेशन के डिवाइसेस कौन कौन सी रजिस्टर हो गई हैं और वो आपस में कम्युनिकेट कैसे कर रही हैं और उनके आपस के मैसेजेस जो हैं वो कैसे पास ऑन करने हैं, these will come under the network management। और फिर उसके बाद कम्युनिकेशन सर्विसेज में पब्लिशिंग एंड सब्सक्राइबिंग का जो और फॉर दैट मैटर लिसनिंग का जो एक एक्टिविटी है वो सारी की सारी किसमें आ जाएगी, कम्युनिकेशन सर्विसेज में, जिसमें कि हम अगर कोई एक्टिविटी कर रहे हैं तो इट इज बीइंग पुश्ड टुवर्ड्स द रेस्ट ऑफ द मशीन्स और डिवाइसेस। तो ये इस टाइप की चीजें, और इसी तरह एक लिसनर होगा और एक पब्लिशर होगा। ये कुछ सैंपल मैसेजेस हैं जो कि हमने जेसन को यूज किया इसमें मैसेज पासिंग के लिए, बीसॉन को भी यूज किया जा सकता है। सो देयर आर डिफरेंट वेरिएशंस। सो कीप थिंग्स सिंपल एंड स्ट्रेट फॉरवर्ड। टेक्सचुअल फॉर्मेट में लाइट वेट मैसेजेस हैं जो कि ऑब्वियसली जो हमारे शॉर्ट रेंज जो ये हैं प्रोटोकॉल्स, कम्युनिकेशन प्रोटोकॉल्स, इनको सामने रखते हुए वी वांटेड टू कीप दिस थिंग प्रीटी सिंपल एंड स्ट्रेट फॉरवर्ड। So these are kind of messages। तो यहाँ पे अब हम समझते हैं कि ये सारी फॉल्ट टॉलरेंस वाली और इस तरह की चीजें हो कैसे रही हैं। तो होता ये है कि हमारे पास जो डिवाइसेस हैं उनमें से एक डिवाइस बिकम्स ग्रुप ओनर। जैसे ही डिवाइसेस आती हैं तो उनमें से एक ग्रुप ओनर बन जाती है और बाकी की डिवाइसेस उसे कनेक्ट करना शुरू कर देती हैं ऑथराइजेशन के साथ। जैसे ही वो कनेक्ट कर जाती हैं तो उसके बाद फिर ये आपस में मैसेजेस एक्सचेंज करना शुरू कर देते हैं। तो लेट्स गो थ्रू इट लाइन बाय लाइन। So what happens is कि हमारे पास बिल्कुल टॉप लेफ्ट पे आपको नजर आ रहा है कि there are 3 devices and they are not connected as of now। What happens next is कि one of them exposes a service and rest of them discover it and connect with that service। तो इस तरह से स्टेप नंबर 2 पे हमारे पास एक नेटवर्क फॉर्मेशन हो जाती है। नेटवर्क फॉर्मेशन के बाद दे कीप ऑन पासिंग इंफॉर्मेशन, दे परफॉर्म एक्टिविटीज। से जिक्सॉ पजल है तो सारे अपने अपने हिस्से का एक कार्ड जोड़ना शुरू हो गए हैं। तो दैट समथिंग व्हिच स्टार्ट्स हैपनिंग। ऑल ऑफ अ सडन व्हाट हैपेंस इज कि एक नई डिवाइस आ जाती है, एक नया दोस्त आ जाता है और कहता है आई वांट टू प्ले एज वेल। सो दे लेट हिम इन। सो जब एक नई डिवाइस आएगी तो क्या होना चाहिए, लोगों ने जितना कुछ ऑलरेडी जिक्सॉ का सॉल्व कर लिया है सोल्यूशन वो उसको नजर आना चाहिए। सो दैट्स व्हाट इट रिक्वायर्स। सो दिस इज व्हाट हैपेंस ओवर देयर। द वर्ड सिंक्रोनाइजेशन एक्चुअली मींस के व्हाटएवर हैज हैपेंड ऑलरेडी शुड बी सिंक्रोनाइज्ड टू दैट डिवाइस एज वेल। और फिर आगे ये तो हो गया एक पर्सपेक्टिव जो कि बड़ा स्ट्रेट फॉरवर्ड है, क्लीन पर्सपेक्टिव। अब हमारे पास क्या हो रहा है कि डिवाइसेस डिस्कनेक्ट भी हो जाते हैं। जिस तरह एक नई डिवाइस ने आके कनेक्ट किया उसी तरह डिवाइसेस डिस्कनेक्ट भी होंगी। तो जब डिस्कनेक्ट में जाएगी तो सेकंड लाइन में भी सी के डिवाइस नंबर ए जो है इट एक्चुअली लेफ्ट, और फिर बाकी डिवाइसेस अपना काम करती रही, सीमलेसली करती रही, कोई इशू नहीं है। और फिर आफ्टर सम पॉइंट इन टाइम वो जो भी डिस्टेंस ज़्यादा हो गया था या कोई हिंड्रेंस आ गई और उस वजह से कम्युनिकेशन नहीं हो पा रही थी, द डिवाइस ए गॉट बैक टू द सिस्टम एंड नाउ व्हाट वी नीड टू डू इज वी नीड टू सिंक्रोनाइज द रेस्ट ऑफ द एक्टिविटीज जो कि उस टाइम फ्रेम में हुई जिस टाइम फ्रेम में डिवाइस ए वाज डिस्कनेक्टेड. सो दैट्स अगेन समथिंग व्हिच वी नीड टू वर्क ऑन. सो हमारा फ्रेमवर्क इस चीज़ का भी ख्याल रखता है. फिर क्या है कि डिवाइस बी जो कि एसेंशियली ग्रुप ओनर थी. So remember in the second line, device A was not the group owner. So group owner is kind of a super peer जो कि गवर्न कर रहा है बहुत सारी चीज़ों को इस पूरे फ्रेमवर्क के अंदर. So in the third case हमने इस चीज़ को हैंडल किया कि अगर ग्रुप ओनर जो है वो डिस्कनेक्ट हो जाता है. Remember these things fall under अभी थोड़ी देर पहले जो मैंने बताया robustness and self adaptation. तो अब सिस्टम ने अपने आप को अडाप्ट करने के यार मेरा तो ग्रुप ओनर ही चला गया तो अभी मैं क्या करूं, बंद हो जाऊं. तो व्हाट इट डज इज इट फाइंड्स अनदर डिवाइस, सुटेबल डिवाइस जो कि ग्रुप ओनर के लेवल पे काम कर सकती है. एंड देन यू सी